All right, everybody, so make sure you take your attendance quiz, get your notebook out, and update your table of contents. Today is the 30th, and we are talking about direct variation. All right, so first thing we need to make sure we all know is what proportional means. Proportional is equal fractions or the same ratio, okay? So if I'm proportional, I have some equal fractions. They are the same exact ratio. Now, the reason why this is important is because direct variation is a proportional linear relationship. So if I'm thinking about fractions, they are equal equivalent fractions. Now, with direct variation, you're going to see an equation like this, where y equals kx. Notice, unlike y equals mx plus b, there is no y-intercept. My y-intercept is 0. But I do have a slope. My k is my constant of variation. Again, otherwise my slope. So, for example, if I had the equation y equals 4x, my constant of variation would be 4. Or in other words, my slope. And then my table would look like this, where x is 1, 2, 3, and so on. My y's are 4, 8, 12, and so on. Since this is a proportional relationship, what happens is every time the x doubles, y is going to double. Notice here, when 4 doubles to give you 8, 1 doubles to give you 2. Same thing goes for if you triple it. If I triple 4 to get me to 12, I can triple 1 to get me to 3. On my graph, I'm proportional because I know I'm going through that origin, okay? When I go through that origin, that's what's showing me that. All right, so in this example, we want to identify our constant of variation. In other words, our slope. Here it's 6, here it's 15. If x equals 8, y equals 24, what is the constant of variation? Well, in my equation, y equals kx. My constant of variation is k. I don't know k, but I know x is 8, and I know y is 24. So what can I do? I can solve for k. Divide by 8 to both sides, and 24 divided by 8 is 3. So 3 is my k for my constant of variation. If you were asked to go write this equation, your direct variation equation, that equation would then be y equals 3x. So on this slide, I want you to identify every equation that is a direct variation. Pause the video and see which ones you think are direct variation. All right, so the ones that are direct variation are y equals negative 8x. Again, no y-intercept. Y equals 9x. Again, no y-intercept. Here I have a y-intercept, so this would not count. Here I have a y-intercept, again, would not count. Same here and same here. This one, however, if I manipulated it, I would see it ends up being a direct variation. I would subtract 5x to both sides. I get negative y equals negative 5x. When I divide by a negative, I get y equals 5x. In other words, telling me all three of those would be equations for direct variation. All right, these right here are the most common types of direct variation problems we're going to get, where I'm going to be told one pair of x and y, and I'm going to be told find the other letter for the other pair. So, for instance, on this first one, they tell me x equals 8. I'm going to write that down, x equals 8. But then they also tell me y equals 24. So on my next set, they ask me, what is the value of x? So they don't know what x is when y equals 12. There are two ways to do this. Way number one is to go back to what you used to do in middle school and cross multiply. notice you don't have something right here. So when I cross multiply, I'm going to do 8 times 12, and it equals 24 times x. When I calculate this, 8 times 12 is 96 equals 24x. I then divide by 24 to get 4 as my answer. All right. Now, there is a second way that you could have done this. Option number 2 was, look at 8 and 24. What multiplies by 8 to give you 24? Well, 8 times 3 gives me 24. So I need to then know what times 3 gives me 12. For opposite, 12 divided by 3 gives me what? 4. So that is another way to do it. I like to do it the cross multiply way, but you can do it this way as well. All right, I'm going to finish this up in part 2 of this video.